Let's dive deeper into the features offered by Pydantic in this video. We're going to look at the field function and how we can use that to set default values, how we can use it to create aliases, and also define the fields that we want to export in our models. We're also going to see some more advanced use cases for exporting the models to JSON and to dictionaries. And finally, we're going to see how to define model config classes in order to define model-wide configuration of a Pydantic model. So let's get started. We have here a blog post that was written. We're going to cover the content of this post, but I'll link it below the video. And this is part of a playlist on Pydantic. If you want to check out the previous two videos, feel free to do that. They introduce some basic concepts in Pydantic, and we're going to build from that in this video. Now, the first thing that we're going to do here is we're going to explore how we can use the field function in Pydantic. I'm going to cross over to the Pydantic documentation here, and it's the schema page on the left hand side here. And this page is the one we looked at in the previous video for exporting your Pydantic models to JSON schemas. But we're going to scroll down, or rather on the right hand side, we're going to click field customization. And you can see here that the field function can be used to provide extra information about the field and about validations. And you can see here that there are a number of arguments you can pass to the field function. These are all optional arguments, and we have values such as default and 𝗏𝗏factory. We're going to look at both of these in this video, as well as things like aliases and titles. So let's start by using the default argument, and we're going to define a default value for one of the fields in our Pydantic model. So I'm going to go back to VS Code. And we have here a models.py file containing our Pydantic models from the previous video. And it's the student model that we're going to amend here. And we're going to look at the modules, which is a list of module models. Currently that has a default value of an empty list, but we can also specify default values using the field function. So before we do that, we need to go to the top, and from Pydantic we can actually import the field function at the top here. And then we can change the statement here on the modules, and instead of an empty list, we can use the field function, and we can pass a default value of that empty list. And that's going to do exactly as the code before did. If there are no modules coming in from our source data set, then this is going to set that equal to an empty list by default. Now, on its own, there's no benefit to using the field function like this instead of simply using an empty list. But there is a benefit if you need to use the field function anyway to define some other arguments. For example, we might want to put a constraint on the length of this list of modules, and we can do that using the max items, and that can be set to a number, for example 10, and that will then throw a validation error if we try and receive a modules object that contains more than 10 modules. In the case where we're using the field function for some purpose like this, we also can use it to define the default value of an empty list. So you can see here that we're building up a field function that contains a validation, and that's the max items validation on a list, as well as a default value. So that works fine for the modules. It can just be an empty list if that data is not present. But what happens if you need a dynamic value as your default? For example, you might want to specify the current date or time as a default value for a date field. And that's exactly what we're going to do. Now, this doesn't really make sense, but we're just going to do it for demonstrative purposes. And we're going to target the date of birth field here, and we're going to use the field function again, and we're going to specify a default factory in this case. And the factory is actually a Python function. It's going to be a lambda function here with no arguments. And we're going to say if there's no date of birth in the data, we're going to set that to datetime.today.date. In other words, that is the current date that we're going to set that to. So the default factory allows you to define a dynamic default value for a field. So let's test this out, and we're going to see if it works. We'll go back to main.py, and I'm going to remove this comment here that we had in the previous video, and we're getting data from a GitHub URL that contains JSON data. And what we're going to do here is we're going to get the last record from this data dictionary by indexing in at -1, and then we're going to get the date of birth field from that particular object. And what I'm going to do is actually remove that from the key value pairs by using this keyword del in Python, and that's going to remove the key of date of birth from the last object in the data. And what we can do after that is go down to the for loop at the bottom here, and for each model in the data, I'm going to print out the date of birth. So let's save that file, and I'm going to bring a terminal over here, and what we're going to do is run this code. I'm going to see the date of birth for each student in the data, and you can see that the 4 at the top all have this date of birth in the 90s, and that's coming from the GitHub data. But because we removed this date of birth from the last user, that particular date of birth doesn't exist for that student. It's replaced with the current date, which at the time of recording is the 5th of April 2023. So you can see that this default value coming from our model from the field function function. It's a dynamic default factory and it's being applied whenever that date field does not exist in the source data. So that covers the default and the default factory attributes of the field function. We're going to move on now and we're going to see how to use the alias keyword. Now let's go back to the blog post that we have here, and I'm going to go down to this section on using the alias here. Now the use case for this is if the field that we want to create on the Pydantic model, if its name does not match the name of the field coming from our API or our external data. For example, we have a student model here and it has a field called name, and that matches the name of the key in this source data set, which you can see in GitHub here. The student has a name, in this case it's 𝗵𝗽𝗍𝗶, but what if we wanted to call this field something different on our Pydantic model? For example, we might want to call the field student name. In that case, we need to use the alias keyword to tell Pydantic what is the name of the source field in our data. And in our case, the name of the key containing the student's name is just name, as you can see on GitHub here. So if we're calling it something different on the Pydantic model, for example student name, we need to use that alias to tell Pydantic what to look for in the source data. And this technique is very handy if you want to map the names of fields in your source data into different names on the Pydantic model, and that's a very common use case because you don't always want to be confined to whatever the names are on the source data set. So you can use the alias for that. We're not going to show a demonstration, but it's very useful to know about that field. Let's move on and we're going to see some advanced uses for exporting models in Pydantic. Now we saw in the first video of this series how to use the .dictionary and .json functions to export a model to a Python dictionary or a JSON string. Now by default that dumps the entire Pydantic model and all of its fields to that dictionary. However, you can actually control this behavior with a field function as well if you want to exclude a particular field from the dumped data, for example. There are two additional keyword arguments to this field function and they both default to false. The first one here is the include argument, and that's a boolean that indicates that only this particular field should be included when you call those dictionary and JSON methods. And the other is the exclude argument, which indicates that that field should not be included when you call those functions. So for example, let's say we wanted to exclude the list of modules from the dictionary or JSON. What we can do is go back to VS Code here, and we have this list of modules here. It has a default value of an empty list, and it has the max items constraint that tells Pydantic that this list cannot have more than 10 items. We can add another keyword argument here, and we're going to set the exclude equal to true here, and that is going to exclude the list of modules from the dumped data when we call one of those functions. So let's see that in action. If we go back to main.py, and within this for loop we're going to print out the model that we get back, and just to print one of them I'm going to break out after the first iteration of that for loop. And what we're actually going to print out here is the model.dict function, and that's going to dump the model to a dictionary in Python. So we can run that code and we're going to see if it includes or excludes those modules. So I've opened the terminal here, we're going to rerun the main.py, and you can see in this output that we do not get the list of modules. If we go back to the models.py file and remove that exclude equals true keyword argument, if we save that and go back to the terminal and rerun this, you're going to see that we get more data, and that's because the modules are printed out. So the effect of adding the exclude equals true keyword argument to a field function is it's going to tell Pydantic when we call model.dict or model.json, we want to exclude this particular field from the output. And that can be useful if, for example, you're working with sensitive data, or if you're trying to reduce the amount of data you're sending over the network, or the amount of data you're transferring between different Python processes. You can use this exclude keyword argument in order to control that using the field function. And we can set as many of these field functions with the exclude equals true as we want. For example, at the top here of the student model we have an ID that is a UUID object. We might not want to expose that to any other processes, so we can add the field function here and set exclude equals to true. If we bring up our terminal and rerun this code again, we are going to see that we don't get the UUID in the output. So this way is useful for security sensitive fields. However, when you're flexibly dumping data, you might not want to have a field definition for every single field that you want to exclude. You can imagine some Pydantic models might have an awful lot of fields. In that case, you can customize your call to the model.dict function. To that, you can pass an exclude keyword argument, just as we did in the field function, and that is equal to a set in Python of fields that you want to exclude from the output. So for example, the ID field and the modules list of modules. We want to exclude those. We've already done that in the field definition here, but we can remove exclude equals true from that, and we can actually remove the field function from the ID itself. If we save that file and go back to main.py, when we call model.dict with this exclude keyword argument, that's another way that we can exclude those two fields from the output without having to write the field definition on the model. So let's test this out. If we go back to the terminal here and we rerun main.py, we should see the same output as we had before, but the difference now is that we're controlling what's excluded through a keyword argument to the model.dict function, and this will work too with the model.json function. The same keyword argument can be applied. If we rerun this, you see we get the output containing the JSON ready data, and we can add as many output fields as we want to the exclude function. So for example, the fees paid, we might not want that in our output, so we can add that down here, and then we can rerun the code and you'll see that that is then excluded from the model.json output. So that works well for excluding fields from our student model, but what if we wanted to exclude something from a nested model? For example, from the module objects in this list of modules, we might want to exclude the registration code, for example. What we're going to do is go back to main.py, and I'm going to define a dictionary under this model object. Now before we define this dictionary, I'm going to go back to Pydantic's documentation, and this section here is on advanced include and exclude. I'm going to link this below the video, and you can see the summary at the top here that the dictionary, JSON and the copy methods, they support those two keyword arguments, which can then either be sets or dictionaries. Now we've seen how to do this with sets when we passed the exclude keyword argument here and set that equal to a set of fields we wanted to remove from the output. But we can also define a dictionary, and we're going to see why we might want to do that if we go back to the documentation and we scroll down here. And it's this paragraph here. It says that special care must be taken when you're including or excluding fields from a list or a tuple of submodels or dictionaries, and that's what we're going to do now. We're going to exclude a field, the registration code, from a submodel, that's the module. We have in the student class a list of these modules, and we want to exclude a particular field from that module, and that's the registration code. If we go back to the documentation, we can see this line here, and that says that to exclude a field from every member of a list or a tuple, the dictionary key all can be used as follows. And if we scroll down to the bottom here, we have here a dictionary of exclude keys, and you can see that when you use a dictionary, you set the name of the field, and the value is a boolean which determines whether or not the field should be excluded from the output. Now that works when you have the fields defined directly on the Pydantic model, but when you also want to exclude fields from a subclass or a list of submodels, for example, we do that here for the address, and we define another dictionary for that key, and that dictionary tells Pydantic which fields from the submodel should be excluded from the output, and you do that using a nested dictionary. But when you have a list of such models, if we scroll to the bottom, if we look at this line of code here, we have the user object, and we're using the dictionary function on that user object, and we're passing the exclude keyword argument to that with a dictionary here, and the key at the top level is the hobbies, and that contains a list of submodels, hobby objects, and to exclude the info field from all of those, we use this all key. So let's see an example now of how we can do that in our own application. Let's go back to VS Code, and we're going to go back to main.py, and I'm going to define that dictionary here called excludes, and we're going to set that equal to a structure that matches what we had on the documentation. Now let's say we want to exclude the ID field. That is defined directly on the student model, so we can just set that to a boolean value of true, and that will then exclude this UUID from the output. But if we wanted to exclude the registration code from each of the modules in this list of modules, what we need to do is we need to use that nested structure here. So what we're going to do is we'll add another key here, and it's going to be for modules, and this refers to the field on the model that contains the list of those objects, and we're going to set that equal to an inner dictionary, and the key we're going to use is that underscore underscore all, and then two more underscores, and that's going to map to a set of fields that we want to exclude from all of the objects in the list of submodels. So in our case, we want to exclude the registration code here, so we're going to copy that and we're going to put it into this list as a string, and on the line below that to the exclude here, we're just going to pass that dictionary that we've defined above. And let's now see if this works. If we go back to our terminal, we're going to clear that out and rerun main.py. And actually what I'm going to do so that we can see this better, at the top of main.py I'm going to bring an import in here, and that's the pprint function from the pprint module, and we can use that function here to pretty print the model.json call. And what we can also do is change the model.json to a model.dict call, and that's going to output that as dictionaries instead of JSON data. So we can now go back to our terminal, and we're going to rerun main.py, and we're going to see what the output is for this. You can see the list of modules is defined now, and the structure of this data is quite a bit better than it was before. But you should note that for each module in this list of modules, we're not getting the registration code, and that is because of this line here in the exclude statement. We take that list of nested modules, and to all of them we are excluding the registration code. If we remove this line of code and go back to the terminal and rerun the script, you can see that the registration code is present in that output. So we need that kind of line here if we're going to exclude a particular field from a list of nested submodels. So we've covered some advanced ways we can dump data to dictionaries and JSON, and how we can exclude certain fields from that data. Let's move on now to model config classes in Pydantic. I'm going to go back to the Pydantic documentation, and on the left hand sidebar we can click model config, and you can see here that behavior of Pydantic can be controlled via the config class on a model or a Pydantic data class. So in the example below that, we have a class called model that inherits from Pydantic's base model, and it defines a field called v that is set to the string data type. And then we have a class, an inner class here called config, and that contains some configuration that's applied throughout the Pydantic model itself. For example, at the top here, we have max any string length set to 10, and that is going to say that for every string field on the class, the length of those strings cannot be greater than 10 characters. Let's see an example of how to use config classes in our code here. If we go back to the models.py file, we're going to focus on the student model here, and you can see that we have a department field, and that's set to an enum. And we defined that enum in the enums.py file, and it contains 3 values. What we're going to do is go back to models.py, and within the student model, we're going to define a class called config. And within there, we can set any configuration we need for this Pydantic model. And one of the configuration fields is called use enum values, and we can set that equal to true. Now what I'm going to do is I'm going to print out each department for every student that we're getting back from GitHub. So let's go back to main.py, and we'll remove the exclude statement here. And what we're going to print out for each model is the model.department, and we can remove the break statement, and we're going to print all of those out. Now what we're going to do is go back to the terminal, and we're going to rerun the Python main.py script. And you can see the output here for each department for the students in our data. And these departments are coming back as string data types, and they're not coming back as those enum values. And that's because we're setting this model configuration within the config class. We're going to say that when we have an enum as a field type, we want to use the raw value of the enum when we're outputting that particular field. Now if we remove this config class and comment it out and go back to the terminal, you can see that the output is explicitly referring to the department enums field when it's outputting those values. So the effect of using this config class with the use enum values set to true is that it's going to take those enums and it's going to output them as raw values, in this case raw strings. And that can be useful for things like serializing your objects, and it's one of many configurations that you can apply in a Pydantic Model Config class. Now we're going to move on to another field we can use in the config class. Let's go back to the Pydantic documentation. And for Model Config, we have on the right hand side under the table of contents, we have options that we can apply within that config class. For example, the title, we can define a title for our Pydantic model, and that's going to be reflected in the JSON schema output. So for example, if I set this title to student model, that will be the title in the JSON schema output. Now we're going to see a particularly useful field here. If we go back to the documentation, it's this one here, it's called extra, and this field tells Pydantic whether to ignore, allow or forbid extra attributes when you initialize a Pydantic model. And when that value is set to forbid, it's going to cause validation to fail if you try and add extra attributes to the model. Ignore is going to silently ignore any extra attributes, and allow will actually assign the attributes to the model. So we have 3 behaviors here. Let's demonstrate how this works now. What we're going to do is go back to models.py, and I'm going to remove this field here called fees paid. Let's delete that from the model. So now the student model is missing that particular field, but the GitHub data that we're using, if we go back to the GitHub dataset, that contains this field called fees paid, and it's set to a Boolean value. So you can think of the fees paid field as being extra data that's coming into the Pydantic model. And when we take this data and we instantiate a Pydantic model, as we're doing in main.py here, we're passing that extra field that's no longer on the model to that model. And the question is, what should Pydantic do when it sees that extra field? And that's what the ignore parameter to the config class does. So let's go back to the class here and the config class. We're going to define the extra keyword argument, and we're going to set it equal to ignore. Now this is the default, and it's just going to say to Pydantic, if we see any extra data in the instantiation of this class, we're just going to ignore any fields that are not defined within the model. If we save this file and go back to main.py, we're going to try and print out model.feesPaid, which remember we've removed from the model. So if we go back to the terminal and run python main.py, you can see that the student object has no attribute of fees paid. So even though the Pydantic model, when we instantiate it on line 13 here, is receiving that fees paid as one of the arguments, it's not going to do anything with it, it's just going to ignore it. And when we try and access that attribute, we get an attribute error in that case, but we don't get a validation error when we actually create the object. Now if you want to be more strict about this and actually throw a validation error if you receive data you're not expecting, you can go back to models.py and we can set extra equal to forbid, and in that case when we try and rerun this code, we're going to get a different error, and that's the extra fields are not permitted. And you can see that the name of the field that we're passing that's raising this error is fees paid. It's no longer part of our Pydantic model definition. It's extra data that we're trying to pass into the model when we're creating that model, and that is no longer allowed when we set the extra parameter to forbid within the config class. Now this can be useful, for example, if you want to avoid any data being serialized that you don't expect, but on the other hand you might actually want to be quite flexible about what you allow on your Pydantic model. So you have a base set of fields here, but you might want to allow extra fields to be added to the model, and in that case you can change forbid to allow. And if we now go back to the terminal and try to rerun this code, you can see we get back the Boolean values that are coming from the GitHub data. And even though we don't have a fees paid field on our model anymore, that extra data is allowed to come into the Pydantic model, and it's set on the attribute called fees paid. So we've covered a few different fields on the config classes. Some are used for JSON schemas such as title. We have things like use enum values that we can set to true, and we also have this very useful extra field that we can use to determine whether or not Pydantic should allow extra data to come into the model, or what behavior to apply when that's the case. Now if we go back to the Pydantic documentation, you can see there are many other fields that we can use in Pydantic model classes. For example, any string upper is going to uppercase any strings that come into your model, and we also have any string lower for the opposite. And you can set things like the minimum and maximum length of strings, and many other things too. For example, here's the one we used called use enum values, and I'll link this page below the video if you're interested in reading about these. But that's all for this video. In this video we've covered a number of different concepts. We're going to look at the summary on the blog post. We've seen how to use the field function to set default values, including how to use the default factory keyword argument to set a dynamic value in the data. We've also seen how you can use the alias keyword argument to handle when fields on a model might have a different name than what's coming in from your source data. We've looked at advanced use cases of the model.dictionary and model.json functions, which you can use to export your Pydantic models to Python dictionaries or JSON strings. We've seen how to use the field function to control whether certain fields are excluded from the output, and how we can also pass keyword arguments to the model.dictionary and model.json functions to control those when we actually call the function. And finally, we've learned about the model config class in Pydantic and how that can be used to apply model-wide configuration to your class. And you can use that config to perform cleanup of raw data, for example by stripping white space or by uppercasing all strings. And we can do some other things such as controlling whether enum values are going to be used, and also the extra keyword argument, which determines the behavior Pydantic applies when extra data is coming to your model. So I'm going to do one more video on Pydantic, which is going to cover model validation in more detail. Possibly there'll be others after that, but if you're interested in anything in particular, please let me know in the comments. Thank you for watching, and I hope you've enjoyed the video. If you have, please like and subscribe to the channel, and we'll see you in the next video.